Hi, my name is Jennifer Rachels, and welcome to my presentation on ethics and data reporting using scale to mislead the public. So our text mentions ethics and data reporting this way. Tables of numbers often hide more than they inform. Graphical displays clearly make it easier to gain insights about data. However, it can be easy to distort data by manipulating the scale on a chart. Our text gives this example, and as you see here, because of the change in scale, and if you can notice that this one goes from 0 to 80 and this one is 0 to 500 along the y-axis, the trends look significantly different between the two. The other example from the text, I used some of the data from a problem in chapter 4 and applied a little bit of poetic license to make it work for my examples. So this is some blood pressure results data given to us at the beginning of the class. And you were supposed to use it to determine whether or not some sort of applied medical intervention stabilized a patient's blood pressure. And you can sort of imagine a scenario where a company, in this case, might be making some sort of presentation to show that their medication is a proven option for a certain demographic of patient. So the stated goal of the treatment is to stabilize blood pressure. And our medical, pharmaceutical, whatever intervention was applied in month 10, as you can see here. And an issue here is whether or not it worked. We have 41 months worth of data. So this is like a cooking show here where I'm saving time by having a step in my process already completed and hidden under the counter. So we'll go to this chart here. And you can see I can change the scale of the data, make it look significantly different by just moving this box around, frankly. I can make it look like the person's blood pressure is relatively stable. I can make it look kind of crazy. So we have a big gap here, though, in the bottom of our chart, which may or may not be necessary. But for the sake of the demonstration here, I'm going to take out, say, under 60. And a good reason to do that might be that, under 60 might mean that you're dead. So there's no reason really to include that data or for data to be there at all. So we can take that part out of our chart. Go back to here. And so that's what I've done here. And you see my peaks and valleys are a little bit more extreme than they were before. And this other line that you see here is a trend line. And to do this, by the way, what I did actually is I clicked on my chart, the entirety of my chart, not just an axis or anything, and went to Chart Design, Chart Element, Axes, More Axis Options. And then you're able to get at that sort of information. And that way you can change the bounds here of your y-axis or your x-axis too if you would like to. But the point I'm trying to make here is that this is the same data, and the data itself has not been manipulated or falsified in any way, and there's nothing unethical going on necessarily. If I were presenting this to the audience I described earlier, medical professionals that I'm trying to sell a product to or to describe a product to, they can be expected to understand why I might have done some of the things I've done with the data and how I presented it. So I'm just demonstrating with this example that scale matters, even if it's simply just a formatting trick or the change of the size of a box. I wanted to talk though, about someone who, or how a person might inadvertently do this with their data in a way that is misleading. Scale and the misapplication of scale can hide common errors. So a manipulated scale can obscure outliers or unwanted trends, and that fits the case that I just presented to you with the blood pressure data. And a researcher may not do that on purpose. In fact, it happens by accident a lot, and scientists have developed ways to test their data and their graphing to make sure that they're not doing this with their data, but they're not perfect. And a manipulated or misapplied scale can also obscure a data sample that is too small in an attempt to show trends when really what you have are just a tracking of individual differences that aren't enough to really represent your entire population. Common errors made with scale by people who maybe don't understand how sensitive data can be to scale manipulation is that um, things can get lost in translation sometimes, and research results are picked up by journalists in particular, or even layout editors. A layout editor might tweak the size of a graph to make it fit into a column or something like that, and they don't really have an understanding of how their small change alters the presentation of the data. This also happens when researchers use scale-related terminology that's really inexact, like rarely or commonly, in that it changes how people interpret what they see on the page. But someone might also use scale to mask their errors deliberately. So again, like I said earlier, you can use scale to, or a scale can obscure a small sample size, but you can use it to do that on purpose. In June of 2000, two doctors of emergency medicine, Marco and Larkin, wrote a paper detailing ethical issues and potential problems in data reporting that were common in their field. And one of the items on their list is this sample size issue. And they say that failing to report the number of eligible participants versus those who actually participated in your study causes a scale issue. In other words, even if you don't change the scale by altering the axes bounds at all, or in any other fashion, but what you really need to do is on the graph itself, come out and say that out of, say, 7,000 people that were eligible for your study, only 200 participated. Even though that makes your sample seem weaker, a weaker representation of your population, um, you have to do it. That's the ethical thing to do. And that's a way that scale can be manipulated that you can't even see on the chart. And that's actually a type 2 error if the disparity is great enough. So in our research, I came across a wonderful handbook on data ethics, and this comes from the Institute of Education Services National Center for Education Statistics. This is part of the U.S. Department of Education, and this is the home of that data that you hear about where U.S. students rank against other countries very poorly in math tests and things like that. And they have a lot of cool things on their website, including files even to upload into ArcGIS for mapping all sorts of stuff. So this handbook is just one of the cool things that they offer. And of what I've read, it's probably the most digestible guide for how to avoid ethical issues that come with data reporting. So they have divided their ethics issues into three major categories: the integrity, quality, and security of data. And the scale issue that we're discussing here, especially as it applies to social issues, is one of the integrity of data. So we'll focus on that. But the whole guide is great, and I plan on keeping it. So guidelines for integrity and data reporting. They have 5 aspects of integrity and data reporting, and scale falls in this one right here, according to their framework. Report information accurately and without bias. They make the point that you need to report your information accurately regardless of how bad the news is. And in the educational realm that these people are operating in, they're usually, their bad news means a lot for their funding. So this is an important ethical issue for them. So here's the example they use to demonstrate how data should be presented regardless of how bad the news is. These test score results on the left show data that appear to be relatively steady performance. It looks like the data shows they're coming in at just below 80 points for the last 7 years on this test, and we'll just assume that that is a test that's from 0 to 100 scale, not like the SAT or anything like that. But on the right, we have the same data with the bounds change on the y-axis, just to a point on either side of the highest and lowest data points that they've collected. And it shows something drastically different. In fact, it shows a pretty steady and somewhat steep decline with the same data. The truth in terms of the presentation of this data is probably somewhere in between these two. Maybe it makes more sense to compare this to the state's average score, for instance, to give some perspective. And also at the center of the y-axis have the minimum score acceptable at the bottom. So it would end up actually looking like this. So here's the information from the slide, and these are the score results that I made. You see I put the data there. And now you still get the truthful downward trend that you see here. But the drama of the drastic drop that you see in score results B up here is taken out, because that's not necessarily true either. Score results A, though, looks a lot more steady than it actually is. So this is sort of the best of both worlds here. And the reason I decided to present it this way is because 60 would be failing. And so this is our state average. And now you see something a lot more interesting, right? That you see that, yes, their scores are falling, but so are everyone else's. So that's just a matter of perspective there. So the National Center of Education Statistics has some best practices guidelines that are meant for practitioners in education, but I think that they would be good for anyone probably to use as just basic starting points. They make several recommendations, but there's one in particular that speaks to this project. They say that you should develop a standard framework to improve the consistency of reports and the presentation of data. And this means that you make some guidelines in your workplace policies about access scales and years reported and what type of graph you should apply, what type of graph style, actually, you should apply to a certain type of data. And this eliminates accidental bias through wrong choices related to any of those factors, but it also lends a predictability to reporting that's helpful to the users of that information. And I feel that this is an important point to make here, because this issue of scale and data reporting is really about transparency for the user, right? Are you presenting your data in a way that it's clear to the user that your data is consistent with your conclusions that you stated, and that you aren't trying to say, as we say in the South, put lipstick on a pig. So moving from the theoretical realm here to real-world data reporting, I'll go over some examples of when scale's been manipulated in the realm of policy and politics. In August of 2012, this graph here was shown on Fox News business show Cavuto. So I got this screenshot from Media Matters. That's a nonprofit. It's a great source for critical analysis of journalistic methods and ethical issues. As you can see here, the y-axis bounds are actually on the right instead of the typical left-hand side. They've been narrowed to just an 8 percentage point range, to the extent that a 2% change, for instance, appears to be a huge change. because it's just relative to the range that we see here. The chart appears to show a tax rate for wealthy Americans that will be more than 3 times what it currently is. In fact, the tax rate is only going from 35 to 39.6, and admittedly, those numbers do occur here at the top. But the visual here is very drastic. And this example shows something to look for as a user of presentation data. Some of the other examples earlier that I used, I did not start at 0, and as I demonstrated in my first example, that can drastically change the way the data appears. So let's look at that. I actually redid that data, starting the graph at 0%. And now the increase doesn't seem quite as drastic, does it? So this is a recent and now actually famous example of scale manipulation that happened in September of 2015 at a special investigative hearing called by both houses of Congress. Representative Jason Chaffetz of Utah showed this chart. Now this is what's called a dual axis chart, and although the axes aren't visible, the user of this chart, I guess, is supposed to just infer them. And that's problematic for a lot of reasons, but these dual axis charts are used, it's also using a different scale of the same unit. So one is plotted in the millions and the other in the hundreds of thousands, as you can see here. So of course that's an issue, but dual axis charts are supposed to show the relationship between two aspects of the same thing. So if we stayed here with this example, the cost of an abortion and their prevalence, for instance. But this chart graphs two totally different things, cancer screenings and prevention services, and abortion, and it uses the same unit, which is number of instances, with a different scale. So the charts you see here in the next slide come from PolitiFact. They're a Pulitzer Prize winning website that's known for fact-checking of political claims. But stats.org called this chart the chart that launched 1,000 news stories, which is true. Show you what the same data looks like. Now, this isn't my chart. This is from PolitiFact again. They got their data from the oversight reports that were submitted by Planned Parenthood to the federal government because they receive a lot of federal funds. They have to report numbers like this. And that's the exact same data. So how does scale affect other types of data presentation and analysis? For ordinary least squares regression, a researcher might rescale data for basically what amounts to cosmetic reasons. They might look at the graphs of their data and determine the graph is very usable or digestible. So they rescale the data, and in this context, what we're talking about is deciding to present something as ounces instead of pounds or kilometers instead of meters. This does change the appearance of the graph, but it preserves the analytic data that you see in your reports, like your standard error and your p statistic. And so we'll look at an example. So this data is from a point-in-time test that's done on Oahu every year. On Oahu, we only have to do a census of homeless people once a year. In other states where the seasonal temperatures are a little bit more extreme, they do it several times a year so they can capture amounts that might fluctuate due to temperature, but we don't have to do that on Oahu. And these are the numbers that they found in each year when they did that census. Now, I made these data up, frankly. Actually, I made up all of these. These numbers do here for the year 2015 do have a basis in reality, but for the preceding years, I made that data up just for the sake of demonstration. And so for this example, the column B here, the overall number of homeless on Oahu, that's my dependent variable, my Y variable. And my independent variables for this example are these two columns, the number of homeless veterans couples and the number of homeless veteran individuals, and also the number of homeless people in substance abuse programs. This is a time series set of data here. And what I want to know is the relationship between the total number of homeless and homeless veterans or homeless people in substance abuse programs. So first I'll try to predict homelessness count based on the number of homeless veterans couples. And I went to data and I ran the analysis and it came out with this. So you see my residual plot here shows that, maybe I don't have the strongest data here. It's kind of all over the place a little bit, not really clustered decently, not distributed decently. But 64% of the overall number of homeless can be attributed to homeless veterans couples, according to my report here. And my model is statistically significant based on the fact that my P statistic is lower than 0.05, less than 0.05. So scale comes in if instead of counting veterans couples, I decide to double that count so I can get individuals. Because as a researcher, I want to be able to show my statistics in a consistent way. Because you see here, these are individuals, right? And originally I just had this number, so I'm going to double that to get the number of individuals here. That way when I report my data later, it's consistent across the different analyses. So let's look at those reports. And what you see is that like all of your statistics are the same. What's interesting here, you'll look at the coefficient. So it's relatively the same. It's halved because the number of people is doubled. I just wanted to point that out. So that's how scale affects regression analysis. And for the record, let's look at whether or not the number of homeless people is better predicted by the number of homeless people in substance abuse programs. And we see from the R-square that it is, and the P statistics tells us that this is a statistically significant result. And I just wanted to point that out. It's actually significantly higher associated with a driver of the number of homeless people overall. So that's the end of my presentation, and I hope you enjoyed it and have a nice Christmas break. Thank you.